Jari said, I came from Czech Republic. I'm working as a network administrator at Brno University of Technology, what is, I think, one of the biggest university, not biggest university in Czech Republic, but it's one of the biggest. At the beginning, let me start with a small quiz which I prepared for you. So, who thinks that IPv6 provides to us better security than IPv4? Please, hands up. Oh, but opposite question, who thinks that IPv4 provides us better security than IPv6? Nobody. Oh. IPv6 looks better, 2% thinks that. So let's see how people think about security in IPv6 more in detail. This screen shows exactly how many people think about security in IPv6. Many people think that, oh, there is IPsec, and this IPsec will solve all problems that we have in our internet. And another thing is that many people claim that there is huge, large address space, so some scanning of address is not possible in IPv6. So let's see more in detail if it's true or not. Let's start with scanning. The scanning is basic activity that hackers have to do when he wants to go into your network. He first have to check if there are some addresses when we can get into his system and try to another issues on this address. So scanning is really important for every hacker, and many administrators may make any steps to rid of the scanning from their networks. It's true that it's a little bit complicated in IPv6 because there are usually subnets with prefix links on 64 bytes, and it is a lot of numbers which the attacker have to scan, and it's not possible. If he wants to do it, he have to run 1 million tests per second, which cause traffic 400 megabits. And in this case, the attacker will find the first active IP address in 28 years. So it's really a long time. But this kind of brute force scanning is not only way how to get this information. There are also other services like DNS, WHOIS, some logs, very interesting service, Query Information Service, Neighbor Query Information Service, which provides information about active address in network, and this system is implemented in some operating systems. And there are also some well-known address in some transition techniques provides us some information about address that we can get from IPv4 address, and this makes this scanning easier. And there is example from one Van Hauser, who is the man who is very deep into IPv6 security, and he joined all these possibilities how to get information about IPv6 address, and result is very interesting. He did the test and get 2,000 active IPv6 address in 20 seconds. It's very nice result. So scanning is a little bit complicated in IPv6, but is not impossible. Something different is, now we were talking about scanning from remote network. But if we move into local network, scanning is very easy. We can try this simple command and then look into the neighbor cache, and we will see all computers available on the local network. Very easy to perform on the local network. So, and also we can sniff information on this multicast group where all computers exchange data about their neighbors, and we also have information about all this data. So what else we can see on the local network? IPv6 brings a very new concept how to work with signalization on a local network. All signalization processes were moved into one big protocol, ICMP version 6, and all this stuff what we did on the local network, like ARP queries and auto configuration, has been moved into this protocol. And ICMP version 6 is very important and essential for IPv6, and we cannot work in IPv6 environment without ICMP version 6. So we cannot block it on firewall for some reasons, and there are other issues which we cannot do on IPv6 with ICMP version 6. If we stay on the local network, there are several types of attacks which we can perform on the local network. Some of these attacks are very similar to the attacks that we can do on the IPv4. The first one, for example, neighbor cache spoofing, is just the same kind of attack as we did on IPv6 named ARP spoofing. It's just the same type of attack. But we have some new kind of attacks, like duplicate address detection. IPv6 implements algorithm to detect if somebody else used just the same IPv6 address on the network. And the computers ask, does anybody use this address? And other computers say, hello man, I'm using this address, try another one. And if we answer to every question, we can do this kind of attack. It was not possible in IPv4. Another problem, neighbor cache tape overload. As we said, there is 64 bytes available for addressing computers in local network. And we can make illusion for the router that all these hosts are available on the network. There is no router who can manage all these records in their cache table. So another way how to destroy IPv6 network. Kind of network that a colleague before me taught, fake router advertisement and DHCP, you already heard about it, and we will talk about it a little bit later. I've already met the person named Van Hauser, and is the author of the very interesting packet set tool, the hacker's choice. You can download it, and this tools allows you make all this kind of attacks on your network. So you can download it, compile it, and try on your network, and you have very simple commands to perform all this kind of attacks that are known in IPv6. And many people think that, oh, it's IPv6, nobody uses it today, and it's not important. It's not a problem because we have IPv4, and it's not a problem. It's only a problem for IPv6. But it's not true at all, because IPv6 works on our computers together with IPv4, and these two words overlaps. You can try this one very simple command from this package that I showed you, and this command causes that all Windows computer on the local network goes down. It's not possible to work with these computers, and it's very easy to do it, and any of you can do it in this network now and destroy all others' computers. Please don't do this. If we stay in the local network for longer, there is another problem with auto-configuration. As I said, IPv6 brings a new concept of auto-configuration, where it's a stateless auto-configuration, where information about routers and prefix routed in the network is provided through this mechanism. Is one kind of message obtained from routers in router advertisement, and there is a problem. This mechanism provides to us prefix and the default router, but doesn't provide to us address of DNS servers. But we need DNS servers in our computer to communicate with other world. So there are a few solutions how to solve this problem. We can obtain DNS servers from DHCP version 4, or we have possibility to use DHCP version 6 to obtain these DNS servers. Some Microsoft operating system implements special anycast address, which we can ask for this DNS request, but this address are on the side local addresses, which we deprecated a few years ago, so we cannot use it also. And another way, a few months ago, there was released the new RFC, which defines new options for router advertisement, where we can set up address of DNS servers. But none of operating system today have implemented it yet. So today we are not able to get address of DNS servers in easy way. So the only way how we can get address of DNS servers today is DHCP version 6. But this protocol is quite new and originally was not planned for IPv6. And there is another problem with DHCP. Okay, we can use either auto configuration or DHCP, but there is another problem. We cannot use DHCP without auto configuration process because there is no default router in DHCP. So in network, if you want to use IPv6 only environment, we have to use both these protocols in IPv6 network, and we have to think about security about both these protocols in IPv6. Another problem is that not all operating system supports both of this configuration. For example, Windows Vista and 7 supports stateless auto configuration and DHCP. But for example, Mac operating system, including all iPhones, iPads, supports only stateless auto configuration. And it's a really big problem if you want to run IPv6 only network, because there is no way how to put address of DNS servers into these devices. So users won't use internet even they have on IPv6 address. And in the Linux and BSD system depends on distribution. And there is a chart taken from our student network which shows number of devices in IPv4 ARP table and IPv6 neighbor cache. And we can see its real network when we can see more than 50% of computers today have already IPv6 address and are prepared to use IPv6 connectivity. So remember the command that I showed you, all these computers on the red line are vulnerable through this command. It's more than 50% of computers today at the network. So what we can do with this? Another problem is that IPv6 is a preferred protocol on most of operating systems. So we can do a very simple attack how to get communication to attacker's computer through this IPv6 network. We can set up a fake router at the network, advertise router advertisement to the network. It's easier if the network is not IPv6 network, it's easier for us, but if network like this network where router advertises also works, is not problem to avoid this routers, original routers, and prepare own DHCP servers, attackers DHCP servers, and put this IPv6 address of the DHCP servers into clients at the network. And then we can very easily modify DNS request and redirect wherever we want. Even administrator perfectly set up IPv6 network through IPv4 network, through IPv6 network, we can go to the clients. So we need big attention for both IPv6 and IPv4 network. Yeah, Some people sometimes say, oh, these problems are very similar. IPv6 have some environment, IPv4 have some environment, and these two protocols are similar. All these issues are just the same. But it's not true at all. In IPv6 world, we have very simple rule. IPv6 auto-configuration means DHCP today. In IPv4, there are some techniques how to prevent this kind of attacks. The easiest one is DHCP snooping, which cut off all fake DHCP servers from the network. And there are some advanced techniques which reads this DHCP request and build own table where is MAC address and IP address. And when the client tries to communicate, the switch compares this address and drop packets which are spoofed or which are not requested by which communicate with address that was not requested through this DHCP protocol. In IPv6, we also have some possibilities. The first one, the very famous one, because it's developed by Cisco, is secure network discovery. It's a system which solves the problem in completely different way, because that expect that all these router advertises packets will be encrypted and signed by cryptography algorithms and checked on the client side if the packet is correct. But there is a big problem. We need infrastructure for private key. This system is based on certificates, and before the client joins the network, he has to get the certificate into his computer, and I think it's not a realistic scenario for real life. And another problem is neither of clients have implemented this technique today. Another solution is a router advertisement guard, which is very, very similar to DHCP snooping, just in a very easy way drops or packet on the access port on the clients which not belongs to router. And there is also cooperation with secure network discovery, where these certificates which we had to have on the client side, we move into switch, and switch do all these checks on his side. Another possibility is Savvy. It's a draft today, and it's complex solution which tries to solve fake DHCP servers, fake router advertisement, and also supports both IPv6 and IPv4 protocol. Problem of RR Guard is that supports only router advertiser, but doesn't provide security for DHCP version 6 request, for example. Yeah, but there is a problem. All these solutions sounds very nice, but they are not implemented in devices today. So we have two possibilities. Either buy all new switches, which are usually more expensive than switches that are not support these IPv6 features, or we will have to find another solution how to solve it. There are some possibilities. My friend Martin told me yesterday that Cisco Catalyst in last firmware also supports AguArt in their firmware, and there are also some less expensive switches than you can buy which supports these features. But it's a problem. All the switches are access switches on the network, and you can afford change all the switches before you deploying IPv6. So you have to find another solution. I will say only a few words about it because my colleague Maciej will have a longer talk about this problem tomorrow. So come here and listen him to about this topic. There are some tools which helps you monitor these fake router advertisers and fake DHCP servers and send some information to administrator, or some of them can automatically recover this information in the network. So if this tool receives some fake router advertisement, immediately send back to the network the correct information. And it's not final solution, but it's solution which can help in our networks today. And there is also some example. You can build IPv6 access list on the switches, but not all access switches support this IPv6 access list, so it might be another problem. Let's see another problem of IPv6. Maybe you know IPv6 brings completely new concept of extensions header, which allows us to put some new features into IPv6, and these extensions headers are created in a very simple way. It's the list of the headers, and at the end of the list there is a exact protocol like TCP, UDP, ICMP, and whatsoever. And there are two kinds of headers. First, extension header, which brings some information for router or for destination client, and as I said, the protocol. There is some order in which order the headers have to go through the network. And there are also some problems related to these extensions headers. All features that we know from IPv4, like options, are moved into these extensions headers. So that means source routing, fragmentation, and many other features are moved into this extension header. And a lot of people don't remember about this extension header and just simply pass through this header on the firewalls. And there is also another possibility to make attacks on these headers. We can make long list of headers. We can manipulate with order of headers, and not all firewalls and not all routers can cope with that. So there will be another kind of problems with these extension headers. Very interesting command is I66 is a tool which generates random header, and you can test your devices if the packets goes through the filter or not. And I think you will be very surprised what this command can do. Try on your router and you will be very surprised. And with extension header, there is another problem. From the format of the header, we are not able to recognize if it's extension header and we should continue going through the list, or is a protocol. And firewalls and other devices working with top of this header, that means protocol, have problem with that, because when firewall find extension header which is not unknown for the device, we then have to decide what to do with this kind of packet. It might be either protocol or extension header, and there are two possibilities: drop the packet, but in this case we remove all extensions in protocol, or try to guess protocol and skip to next position. But it's a problem if the extension header is a protocol. We can read this information from numbers, which means something else, and we can go into incorrect path. So there is on the Cisco, for example, very important command which allows the switch drop all unknown headers going through the switch and switch the switch or router into this first mode. Not many people knows about it. And another problems, IPv6 is here for 15 years, and a lot of work has been done to IPv6, but IPv6 was designed as the easier protocol, which should improve IPv4. And there is a lot of experiences from IPv4, so all programmers and all people who are doing software should be experienced and should not repeat the problems that we know from IPv4. But there is a lot of problems, a lot of bugs that appears in IPv6 again. Many of these bugs have had in IPv4 many years ago, but now we have just the same bugs in IPv6 again, because the reason is very easy. There are two independent kind of software, two codes in all systems, and we have to repair it on two places. So there were 47 bugs in 2 years, quite important bugs, which must be repaired in IPv6, and there is a lot of bugs in IPv6 today, again, which are not covered yet. So, what's conclusion from that? IPv6 actually doesn't bring any better security model for internet for new generation. It's a very similar protocol to IPv4, so that means that all issues known from IPv4 are in IPv6. Illusion that IPsec solve all this problem is not true at all, because IPsec solves some kind of different problem. It solves protection on the way, but not solves problem like router advertises and many other. Some problems are more difficult to perform, like network scanning, but it's not too much. I think brings IPv6 at all brings more complicated, more problems, and we will have to solve it in future. So it's a challenge for us. So I think that's all from my side. Any question? The only things I want to say that IPv6 is not magic solution for all problems. We also will have problems, and we'll also have to work on these problems, and we have to put same attention as for IPv6 or as for IPv4 in the same way. It's the thing what I wanted to say. IPv6 have same importance as IPv4 today, and it's not easy to make some shortcuts in that way. Okay. Any questions?